QGIS is a free and open-source cross-platform desktop geographic information system application that supports viewing, editing, printing, and analysis of geospatial data. In this video we go to QGIS software and show you how to use this powerful software from A to Z. So stay with us and let's get started. To get started, you need to download and install the QGIS software. If you don't know how to download and install QGIS, we have already recorded a tutorial for it. You can refer to the description of this video and find tutorial link. You can easily download and install the latest version of the software using that tutorial. If you have already installed the QGIS, so open it. To avoid any unwanted errors, we recommend you to install the latest version of the software. At the bottom of the page, a link with the latest version of the software can be seen. By clicking on this link, you can download the latest version of the software from the QGIS website. In this section, you can download QGIS based on your platform. QGIS consists of several parts. Browser panel through which you can import all your data into the software. Layers panel, in this section you can view all your layers and manage them if needed. The display section of the software where all the layers are displayed in this section. The processing toolbox panel, where all software processes are found in this section. You can go to the processing section and find your processing commands, or you can also search in the search section to find the processing command of your case. It is an important and basic part of the software, where all our work is done from this part. Right-click on a blank section of the software. All panels and toolbars are displayed here. By clicking on each one, its tick is turned on and displayed inside the software. So you can use this section to manage panels and toolbars. There are several ways to import your data into the software. The first way is to use the browser panel. Using this panel you can go to your data storage path and select any layer or data you need and import it to the software. As an example, we import a shapefile into the software. It is imported to the software either by double-click or by right-clicking on the layer, Add Layer to Project option. You can delete it by right-clicking on the layer. You can import raster files and vector files into the software. For example, we import a raster file into the software. Then we go to a storage path to save the image and select TIFF. The image can be seen here. You can go to Layer Properties by right-clicking on the layers. Here you can see the properties of the raster layer. You can save data folders separately in the first browser panel. By using this, you can access your data storage more quickly. Right-click on the desired folder. Click the Add to Favorite option. Here you can see that our folder has been placed on top of the other folders. In this way, you can import your layers into the software in the shortest possible time. The second method of importing layers is to use the Open Data Source Manager tool. By clicking on this option, the Data Source Manager window will open. Here the browse is visible again. As you can see, the desired layer imported to the software. In the vector section, you can import all the vector layers into the software. You can specify the sensor type. Select the desired layer. Here are most of the formats, and you can choose any of these formats based on your needs. Here there are various formats so that you can import your layers into the software based on your needs. To perform Symbology, you need to import your layers into the software. Here we have the polygon and lines layer. To do Symbology, you need to go to your layer and right-click, select the Layer Properties option. We can change the appearance type. Click on the layer. You can also change the symbol layer type. You can choose the color combination. There are various color combinations in the Select Fill Color window. You can specify the color combination manually. You can display your layer based on HSV and RGB as well. By clicking on your layer, you can have all kinds of samples to display the layer. It is the same for lines. You can specify the color combination manually. You can display your layer based on HSV and RGB. You can increase or decrease the width for lines. Project styles can be selected based on needs. Choose the appropriate project styles for line layers. You can use various display modes and display layers in different ways. For our layer, we used a different color combination. So that each polygon is placed in a group with a specific color combination. In order to get an output or layout from your layers and maps, you need to proceed according to the tutorial. For this purpose, select the new Print Layout option. Assign a name. In the open window, you can adjust the map. This is the main section of layout. There is a blank page that requires a series of settings to be made on this page. On the left side, there are a series of tools for editing the output map, which we will use in the continuing. Also, on the top of the page, there are tools for saving, exporting, etc. On the right side of the page there are options for settings inside the map. There is an option called Item Properties, which you need to use in the first step. Here you can specify the page size. As seen in the list, you can choose one of these items based on your needs. We put on A4. We put the orientation on the landscape. As you can see, you can choose the desired style for your page. To add your layers to the map, use the Add Map command. Click on the tool. Draw a polygon on the screen to add layers inside this polygon. As you can see, the layers have been added. You can change its size and make it bigger or smaller. Item properties will be displayed when you click on the map. Here you can make settings related to the map. You can change the scale manually. To add a title on the map, use the Add Label tool. By clicking on this option, you can draw a polygon on the map to add a name on the map inside this polygon. These steps are optional, you can set them as you like too. Assign a name for the map. You can change the text font. Or you can change the text style. And change the text size based on your need. You can also change the color of the text. Place the text in center and middle for better appearance. Select the Add North Arrow option. Then click the Add Legend option. The map legend is displayed. After preparing the map, you can export the final output. Assign a name for the output and a specified storage path. The final map has been exported and can be seen here. In this section, we are going to go to some geoprocessing tools or operators that are really applicable and useful in every project. We apply a few of them, but you can use any of them in the same way. The first one that we want to apply is Dissolve operator. To briefly explain, this algorithm takes a vector layer and combines their features into new features. In other words, it is a process in which a new map feature is created by merging adjacent polygons, lines, or regions that have a common value. To apply the dissolve, from the vector toolbar select Geoprocessing tool, then click on Dissolve. Another way to reach the dissolve is search bar. You can simply search for dissolve from the search section of the software to reach it. As mentioned earlier, the dissolve operator takes the vector layer as input, so we define our shapefile layer as input. In the dissolve field section, you can select the field that you want to perform dissolve based on that. You can set an output path if needed. As you can see, the smaller polygons were dissolved into larger polygons. You can use this method in some works. In the next step, we will perform the clip operator. This algorithm clips a vector layer using the features of an additional polygon layer. Only the parts of the features in the input layer that fall within the polygons of the overlay layer will be added to the resulting layer. To apply the clip, the same as the dissolve, select the Geoprocessing tool option from the vector toolbar. In the open list, select the clip command. Import your layer as the input layer. And in the next step, select Overlay Layer. Specify a name and a path to save the output. Here the clip output can be seen. For better learning, we import another layer in the software to perform the clip operation again. Here you see a series of polygons that characterize the imaging of a particular type of sensor. We are going to clip this shape file based on the yellow area. Specify the input layer. And in the next step, select Overlay Layer. Specify a name and path to save. Here the clip output can be seen. As you can see, the extra parts of the shape file were trimmed and clipped exactly based on the yellow layer. Sometimes in some projects you'll need to specify how many points a polygon cover. For this purpose, the count points in polygon command is used. This algorithm takes a points layer and a polygon layer and counts the number of points from the first one in each polygons of the second one. In other words, it is a spatial operation in which points from one feature dataset are overlaid on the polygons of another to determine which points are contained within the polygons. From the Vector section of the Analysis Tools option, select the Count Points in Polygon command. Choose your desired polygon layer. Select the points layer as well. You can specify an output path. A new layer is generated in which the number of points is specified for each polygon. Go to the attribute of the layer. The last column shows the number of points inside each polygon. For the next section, we will use the Difference tool. This algorithm extracts features from the input layer that fall outside, or partially overlap, features in the overlay layer. Input layer features that partially overlap features in the overlay layer are split along those features boundary. And only the portions outside the overlay layer features are retained. Attributes are not modified, although properties such as area or length of the features will be modified by the difference operation. If such properties are stored as attributes, those attributes will have to be manually updated. For this purpose, select the Geoprocessing Tools command from the Vector section. Select the Difference option. And select your desired layer. And run. The output layer that you see is a part of the empty layer that we removed using the second layer. In your opinion, what is the difference between the clip and the difference tools? Comment it. The next operator is intersection. This algorithm extracts the overlapping portions of features in the input and overlay layers. Features in the output intersection layer are assigned the attributes of the overlapping features from both the input and overlay layers. We display the two layers on which we are going to apply intersection. For this purpose, select the Geoprocessing Tools command from the Vector section. Select the Intersection option. Select the two layers you want to apply intersection to. Here you can see the final result of intersection. The next command is Symmetrical Difference. This algorithm extracts the portions of features from both the input and overlay layers that do not overlap. Overlapping areas between the two layers are removed. The attribute table of the Symmetrical Difference layer contains original attributes from both the input and difference layers. For this purpose, select the Geoprocessing Tools command from the Vector section. Select the Symmetrical Difference option. Select the two layers you want. Here is the specified symmetrical difference output. If you need to make two layers the same without destroying the classification of each class, use the union option. This algorithm checks overlaps between features within the input layer and creates separate features for overlapping and non-overlapping parts. The area of overlap will create as many identical overlapping features as there are features that participate in that overlap. For this purpose, select the Geoprocessing Tools command from the Vector section. Select the union option. Select the desired layers. You can see the union output. In some cases, the existence of different shapefiles makes it more difficult to display. In these cases, you can display the layers more clearly with a series of effects. In this section, we will show you live layer effects. For this purpose, click on your layer. Click on the Layer Styling option. Then select the Layer Rendering option. Toggle on the Draw Effects option here. Click Customize Effects in front of Draw Effects. You've entered the Effects Properties section. Here you can use different options to create effects on your layer. As you can see, polygon lines are displayed as different effects. Based on the layer and your area, you can use any of the effects. Here, the changes in the effect of the layers can be clearly seen. You can use this method to better display and even output maps to have more visually beautiful maps. In this section, we will perform HeatMap. Creates a density, HeatMap, raster of an input point vector layer using kernel density estimation. HeatMaps allow easy identification of hotspots and clustering of points. The density is calculated based on the number of points in a location, with larger numbers of clustered points resulting in larger values. You can invoke the HeatMap in several ways. The simplest way is the search bar. Search for HeatMap in the search section. In the open window, you can select your own layers and run to generate HeatMap. Also, go to the Symbology section by double-clicking on the layer. And select the HeatMap command at the top. You can make a series of settings on your layer. You can change the unit. It can be based on points or pixels in other cases. You can specify a different color combination for the output. Do you need to download images and different types of layers? Bing, Esri, Google, USGS, OSM, Yandex, etc. Here it is. In this video, we will show you how to download all the mentioned images in the best quality in the shortest time. To get started, you need to install a plugin. For this purpose, go to the Plugins section. Among the plugins, search for Quick Map Services plugin. Select and install the plugin. As you can see, the plugin's been successfully installed. We select the plugin from the web section. For example, choose Google Satellite Images. To learn to download these images, go to the region that you want to download images for. From Processing Toolbox, choose Raster Tools command and convert map to raster command. Using this tool, you can convert a map to a raster. Select your area. For the map units per pixel option, the larger the number, the less accurate the image will be. So, we test the number 1 for this purpose. Here the desired image was correctly extracted. Select Convert Map to Raster again. And this time give lower units per pixel with map. The smaller the map units per pixel and the larger the area, the longer it takes to export. You can export the image. We also display other layers. In some cases you need to change the coordinates of the layers. This algorithm reprojects a vector layer. It creates a new layer with the same features as the input one, but with geometries reprojected to a new CRS. For this purpose we've produced this part of the tutorial. To perform this, you need to enter the vector file. In this section, select the Data Management Tools option. And finally select Reproject Layer. In the open window, you can introduce your desired layer. You can specify target CRS. In the first step, we convert the coordinates to Mercator. Here is the changed coordinate system of the new layer. We do this step again. And change the coordinates based on UTM this time. You can change the coordinates of your layers to have better processes in this way. This algorithm calculates the angle of inclination of the terrain from an input raster layer. The slope is expressed in degrees. To apply the slope, you'll need a DEM, so we import a DEM layer into the software. For this purpose, use the Data Source Management tool. Go to the raster section. Select your layer from the requested path. And click Add to enter the software. Go to the raster section. Select the slope command from the analysis section. Enter your layer. That's it, here is the final output. Now, we're going to customize its appearance, so we go to the Layer Properties section. And select Render Type from the Symbology section. We set it on Platted. And choose a color combination. Here you can see the slope command output. Aspect command generates an aspect map from any supported elevation raster. Aspect is the compass direction that a slope faces. The pixels will have a value from 0 to 360 degrees measured in degrees from north indicating the azimuth. To perform this command, go to the raster section. Select the aspect command from the analysis section. Select the desired layer. You can set an output path. Done, here you can see the aspect output. Hillshade outputs a raster with a nice shaded relief effect. It's very useful for visualizing the terrain. You can optionally specify the azimuth and altitude of the light source, a vertical exaggeration factor and a scaling factor to account for differences between vertical and horizontal units. To apply this command, like slope and aspect, select the Hillshade option from the raster and analysis section. Enter the desired layer as input. Note that the input must be a DEM. You can define a storage path to the output. You can change some parameters. In the first step, we do it by default. Here is the Hillshade output. Brighter areas are areas where the sun shines directly on these areas. Select the Hillshade again. Change the azimuth of the sun this time. By changing the azimuth, the angle of the sun will be different. A contour line is a line drawn on a topographic map to indicate ground elevation or depression. A contour interval is the vertical distance or difference in elevation between contour lines. Here, to extract contour lines, you need to go to the raster section. Select the contour option from the extraction section. The input should be the DEM layer. You can also specify the distance between two contour lines. Here we set it on 10 meters to start, so that a contour line is created for us every 10 meters. Because we have a large area and there are many 10-meter lines in this area, it will take some time. A better color can be chosen. Areas with a high density of contour lines have more extreme elevation changes. On the contrary, the areas with lower density do not have many changes in altitude. Once again, we set the distance between the two lines on 80 meters. Here the changes in the contour lines are clear. If you want to crop a raster layer based on a vector layer, see the rest of the video. For this purpose, we import the DEM and polygon layer into the software. We select the extraction option. And select Clip Raster by Mask Layer option here. Insert your raster layer. Also specify the vector layer. You can also convert the coordinates at this stage. And export your layer based on any coordinates you need. You can specify an output path. Here the raster layer was cropped based on polygons. Relief. This algorithm creates a shaded relief layer from digital elevation data. To better display of the DEM data, we use this command to have a better view of the area. Import the DEM layer into the software. Select Raster Terrain Analysis from the Processing toolbox. Here select the Relief command. In the open window, enter the DEM layer in the input field. You can specify the classes in two ways. Automatically and manually. You can classify automatically by ticking Generate Relief Classes Automatically option. And also, in the lower part, there is a tool that you can specify the threshold limit of the classes along with the color of that class. As you can see, the relief result shows the area well. Areas with higher altitude are seen in black and areas that are lakes or pits are seen in lighter color.